of the coordinate systems. So Wednesday's class, we looked at cylindrical coordinates, which was basically the 3D extension of polar coordinates in 2D. So we had normal polar coordinates, and then we just have a z coordinate, traditional z coordinate that goes straight up. So we can use cylindrical or Cartesian rectangular coordinates to define points in space. They are not the only coordinate systems. So today we're going to look at another 3D coordinate system. Again, this probably should belong in Unit 1, where we're just learning about how 3 dimensions work. But just so to not give you a horribly long exam, it does kind of bleed into this second unit. So we're just getting used to writing coordinates in a different kind of space. We're going to talk about spherical coordinates. So we have an ordered triple, which now we're going to have rho, so this is the Greek letter rho, theta, it's actually the same theta that we saw last time, and the Greek letter phi. Phi, or phi, okay. Phi.
Yeah, phi.
So just remember, rectangular, you have x, comma, y, comma, z, cylindrical. You have r, comma, theta, comma, z. And now our new one is spherical. You have rho, comma, theta, comma, phi. So our first coordinate, rho, is defined as the distance from the origin out to the point that we're interested in. And we might think for a second, didn't we call that r? We actually called this dashed red line here r. R was how far out did you go from the pole out only in the xy plane before you traveled up. So this is now the straight line distance from the origin to our point. So we get this idea of kind of why it's spherical, that it goes out in any direction. That's our rho. Theta, you're gonna like this one. Theta is the same theta from cylindrical coordinates. It's from the positive x-axis, how far did I sweep out to reach? How far of an angle did I sweep out to reach that coordinate? And now our new one is another angle. So in spherical coordinates, you have 2 angles and 1 distance. This angle now is from the positive z-axis. How far did I sweep out to reach my point? So something I want to emphasize here for phi, you're only going to go between, this will only be between 0 and 180. The reason is, if I go past 180, and I go just a little bit more, now you could have just talked about this angle that goes from here to here. So we're going to try to leave this between 0 and 180. Right. Question so far? I know it's really hard to look at 2D pictures of things we're trying to represent in 3D. So what we were calling R in cylindrical coordinates is now this line here. This one? Yeah. That is Z. So looking at our toolbox here, we have different ways of converting. So this is just something in our toolbox, on our reference sheet. This kind of should feel a little bit like cylindrical coordinates. For cylindrical coordinates, we had x equals r cosine theta. Well, that idea is still present here. It's still something cosine theta. And y is still something sine theta. The only thing now is we're just making kind of a substitution here, and we're going to talk about rho sine phi. Rho sine phi for both. Cosine theta, sine theta. Now, where exactly are these coming from? I can post videos on Blackboard. Me trying to do demonstrations on a 2D image might not go well, but we can see we have like triangles here, and we can create a right triangle, this right triangle. You could do some trigonometry to find z, which if I have my angle, I can play around with some symmetry and do adjacent over hypotenuse. But me trying to show it in a 2D image will be brutal, so I will leave that to some videos I will be posting. So now let's practice converting spherical coordinates to rectangular. So if I give you the coordinate in spherical coordinates, 3, pi over 2, pi over 6. Just a reminder, now in spherical coordinates you have one distance and 2 angles. So this is saying go out a distance of 3 units. If you want to think of it as kind of like going out along the positive x-axis, then sweep at an angle of pi over 2. And now from the positive z-axis, sweep down pi over 6. So you're going to get something that extends out 3 units, kind of opening up along the y-axis, and pi over 6, or 30 degrees, out from the positive z-axis. So just being able to think about what the coordinate means, now let's actually convert it. I've got x equals rho times the sine of phi times the cosine theta. The biggest thing that's going to mess us up is just remembering kind of which one's phi, which one's theta. Just remember the second coordinate is theta for both cylindrical and spherical. There isn't some last minute substitution at the last second. The second angle is phi, I just did it, is theta, the same way that it was for cylindrical. So I've got rho sine phi cosine theta. Then rho sine phi sine theta. And then rho cosine phi. And now we just whip out our unit circle. The sine of pi over 6 is 1/2. The cosine of pi over 2 is 0. Sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2. cosine pi over 6 root 3 over 2. So now we've got x, y, and z.
For y, isn't it sine theta?
Pi over 2 for sine. Yeah, thank you. And sine of pi over 2. So we get 3 over 2.
3 over 2. Okay.
So now, thinking about this coordinate, this is now rectangular. This is saying don't go out along the x-axis. Only go out in the y direction and then go up. And thinking about that again in spherical coordinates, that was saying rotate at an angle of pi over 2, which lines me up with the y-axis. Sweep down an angle of pi over 6, so I'm still kind of living in that yz plane, and then open out a unit, a distance of 3. Questions? So, same process, just doing it again. You have a spherical coordinate, convert that to rectangular coordinates. So pause for a second once you've got that. Just kind of making sure mentally we're keeping up with what these coordinates are saying and ask ourselves, do these points make sense? This is saying go at a distance of 2, you have a theta of 3 pi over 2. So I'm going to sweep from the positive x-axis, this would be my pi over 2, pointing back there would be pi. So this is my 3 pi over 2 for theta. And now from there I'm going to sweep down pi over 4. So I need to be opening up along this negative y-axis. And that's exactly why I see a negative y-coordinate and no x-coordinate. I'm not opening up along in the x direction. I'm only going out in the negative y direction. A positive z-coordinate because I'm sweeping down at an angle of pi over 4, which is less than pi over 2. Anything more than pi over 2, you would then have a negative z-coordinate. How are you?
Is this kind of like how we're gonna be asked on the test, or maybe it works?
Yeah, so that's a good question. So for unit 2 purposes, it's really not going to be too bad. Here's a coordinate, convert it. Here's an equation, convert it. In unit 3, when we want to do stuff with it, it's implied that we know what's going on in these coordinate systems.
Can you go over real quick how you got sine of 3 pi over 2 is negative?
So unit circle. 3 pi over 2 is straight line, and the y coordinate is the sine, so that's the negative.
So when you're asking for the sine, it'll always be the y coordinate?
And the cosine is the x coordinate. Oh no.
Uh-oh, they must have wiped it in.
I think it's the cold. Alright, we're gonna move on. So the next thing in our toolbox is converting from spherical to Cartesian. I'm sorry, I said that backwards. From Cartesian to spherical. So now if I have some x, y, z, can I describe it as the straight distance out and those two angles? So we said rho is the distance from the origin from 0, 0, 0 all the way out to our point. So what we see, rho is just a distance formula from the x, the y, and the z. So it gives you that straight distance. So that makes intuitive sense. Theta, well, I promised you from last time that theta is still theta from cylindrical, so that never changes. Theta is arctangent of y over x. And now our new one, phi, is the arctangent square root of x squared plus y squared